Welcome to the lesson on ratio tables, lesson 4. This will look very familiar because we've already done multiple tables and ratios and multiples are related. So it says use ratio tables to find pairs of numbers that have the same ratio. Pairs of ratios that have the same ratio are called equivalent ratios. So we're looking for equal ratios. That big fancy word equivalent means equal ratios. So let's look at our first example. It says a punch recipe uses 1 container of soda and 3 containers of juice to make 1 batch of punch. How much soda is needed to make 2 batches of punch? So if we look at a ratio table, we can compare soda and juice. And 1 container of soda would require 3 containers of juice. So that means 2 containers of soda would need 6 containers of juice, and 3 containers of soda would require 9 containers of juice. So these are ratios because you're comparing 2 different quantities. And the ratio of 1 to 3, 2 to 6, and 3 to 9 are equivalent. They are equal, since each simplifies to a ratio of 1 to 3. Equivalent. All right, let's look at the second example. To make yellow icing, we're making a cake, yum. To make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So we are comparing 6 drops of yellow food coloring to 1 cup of white icing. How much yellow food coloring should you mix? With 5 cups of white icing. So in our ratio table, we will indicate what 2 different quantities are being compared. And let's name them because when we get into word problems, it's really important that we know what we're comparing and know which numbers match those words. So we have drops of yellow food coloring, which is 6. And we have cups of icing, which is 1. So the ratio starts as 6 to 1. Well, I want to get to use 5 cups of icing. So I have to think, how do I go from 1 to 5? I multiply by 5. So whatever I did to that bottom ratio, I do to the top ratio. So 6 times 5 is 30. So it would take 30 cups of white icing to get the same shade. Okay, in a recent year, oh my gosh, this one. In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. Can you imagine? If he ate at a constant rate, determine about how many hot dogs he ate every 2 minutes. Okay, so we have our ratio table comparing hot dogs to time. That would be minutes. Put it in words. And then let's fill in the ratio. They're telling us 66 hot dogs in 12 minutes. Well, we want to know how many hot dogs he can eat every 2 minutes. I don't think it's necessary to do this. How do I go from 12 to 2? They divided by 2 and divided by 3, but I know the GCF of, well, one of the factors, and I think the GCF of 66 and 12 is actually 6. So if I divide by 6, 12 divided by 6, I get 2. And if I take 66 and divide by 6, I get 11. So at that rate, he can eat 11 hot dogs every 2 minutes. And if you think about it a little bit further, how many can he eat in 1 minute? 11 divided by 2 is 5.5 or 5.5. So he can eat 5.5 hot dogs in 1 minute. Wow, talent. All right, next page. What we're going to do is something called scaling. So we're going to multiply or divide, kind of going back and forth. So multiplying or dividing two related quantities by the same number is called scaling. Sometimes you may need to scale back. That means you're going to divide. Or sometimes you may need to scale forward. That means you will multiply to find an equivalent ratio. So let's take a look at number 4. Cans of corn are on sale at 10 for $4. That's our rate, which is a ratio. Find the cost of 15 cans. So we want to find an equivalent ratio. So in my table, I'm comparing cans of corn to cost in dollars, and they've told me it's 10 to $4, 10 cans of corn for $4. All right, how can I find the cost of 15 cans of corn? So I need to get from this 10 all the way over to 15. Is there something I can multiply 10 by to get to 15? No. That's why I'm going to scale back. I'm going to divide 10. Both 10 and 4 have a common factor of 2. So 10 divided by 2, I'm going to divide 10 by 2 and see what I get. Divide by 2 and I get 5. Can I get from 5 to 15? Yes, by multiplying by 3. So you can see I scaled back by dividing 10 divided by 2. Then I scaled forward by multiplying 5 times 3. Now that I should be able to do with my 4. So if I take 4 and divide by 2, I get $2. 4 divided by 2 is $2. Now with my $2, I do the same thing I did to the 5 above. I multiply it by 3, and that gives me $6. So divide each quantity by a common factor. That was 2. And then, since 5 times 3 is 15, multiply each quantity by 3. So my final answer, 15 cans of corn would cost $6. So we can see the original ratio of 10 to $4. We needed to get that to 15 cans, and we saw it in our chart, it was $6, but it's really difficult to go from 10 to 15 without scaling back, dividing first. All right, let's take a look at a problem together. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. Wow, what a long day. All right, at this rate, how many lawns could he mow in 49 hours? So let's take a look at the two things that are being compared. 14 hours for 8 lawns. Okay, so 14 hours last week. So we're comparing hours to lawns, or is it lawns to hours? Yes, hours to lawns. Okay, and originally they told me it took him 14 hours to mow 8 lawns. That's my ratio. At this rate, how many lawns could he mow in 49 hours? I'm going to match that 49 with my top ratio of hours. So is there a way for me to get from 49 or from 14 to 49 by multiplying it by something? Let me check off to the side. 14 times, let's see, 14 times 4 is 56. That's too big. 14 times 3 is 42. That's too small. So there's no way to get from 14 to 49. So what I want to do is I want to scale back. I want to make that smaller. I know 7 goes into 49. So if I divide 14 by 2, that'll give me 7. Okay, and then I know 7 times 7 would give me 49. So I'm going to do the same thing to my 8. I'm going to divide 8 divided by 2, and that gives me 4. Now I'm going to do the same thing I did above with that 7. I'm going to take the 4 and multiply it by 7, and I get 28. Okay, so that middle part I had to scale back here, and then scale forward so I can get from 14 to 49. So basically what we're saying is 14 hours for 8 lawns is equivalent to 49 hours for 28 lawns. But as you can see, there's no way you can multiply by just one number here or here. So that's why we scaled back and scaled forward. So now we can see Joe can mow. Here's my answer, 28 lawns in 48 hours. Okay, we are going to stop here because it's getting to be a long video. Try number 6 on your own. I've given you the chart. Try number 7 on your own and come back with any questions you might have. Have a good afternoon or evening.